Good afternoon, everyone. I, Rupali Gupta, Assistant Professor, Department of Information and Technology, IMT College of Engineering, Greater Noida. Today, I am here to tell you something about support vector machine. So, first of all, let me discuss what all topics today I am going to cover in my PPT. First topic is introduction to machine learning. Then we will be discussing about the types of machine learning. Then what is SVM, how SVM works, what is support vector in SVM, and what are the types of SVM. These all topics today we are going to cover. First of all, let me discuss what is machine learning. So, as the name signifies, machine learning. So, basically, machine learning is the ability to make machines learn through data by using various machine learning algorithms. As you know that machine learning is also a type of artificial intelligence, or you can say that artificial intelligence is the broader term for the machine learning, and the machine learning is the subpart of artificial intelligence. So basically, what is machine learning? Machine learning, for machine learning, data is the basic keyword which we will be using. So basically what we do, we provide the data to the machine, and what the machine do, it takes the historical data and the current data, and on the basis of that, it predicts the future. So basically machine learning is the science of getting computers to act by feeding them data and letting them learn a few tricks on their own without being explicitly programmed to do so. So basically, what we do, we make the machines learn themselves. As machines are just like a human being, as what we human do for learning anything or for learning any new concept. What we do, we collect the data, and out of that data, we analyze that data, and we find the useful aspects out of that data. In the same way, machine also do the same thing. Machine also collects the data. What we do as a human being, we just feed. You just see in my next slide, there is a feed. What we do, machine can be anything. It can be a system, or it can be any other machine. What we basically do, we feed data to the machine, and we keep on feeding. Machine also contains some data already, and we keep on feeding the new data to the machine. On the basis of that, on the previous data as well as on the current data, what machine do, machine analyze that data, it process that data, and it predicts some output out of that data. So this is what basically machine learning do. So the more data we feed, the more accurate result we will be getting. As being a human being, everyone knows that the more we read, the more we study, the more accurate we are. In the same way, machines are more accurate if we feed more data, because from the data they predict something, they learn something, and they will be getting some fruitful results out of it. So basically, machines is the ability to make machine learning is the ability to make machines learn through data by using various machine learning algorithms for analyzing and for getting the useful insights out of that data. So this is the just a basic diagram. So we keep on feeding the data, and out of that data, machine predicts some output. So next topic is types of machine learning. So in types of machine learning, basically we have three types: supervised, unsupervised, and reinforcement learning. But here we are going to discuss only the supervised learning and the unsupervised learning. As the name signifies, supervised learning. So supervised learning is the type of machine learning. So what is basically, it is also a type of machine learning because it is a part of machine learning. So basically, supervised learning is the learning in which we have some supervision. We have some supervision. We have some trainer, out of which we will be training that data. We keep on labeling that data. What we do, we input the data, and we input the data which is the label data. because it is being, we know that what will be the input and what will be the output. So as for one of the best example for supervised learning is the student and teacher relationship. So what the student do? Student learn from the teacher. So what is that? Students are learning something in the supervision of teacher. So that is why we call it as a supervised learning. So supervised learning is what? Supervised learning is the type of machine learning in which machines are trained using well labeled training data, and on the basis of that data machine predicts the output. And the label data means some input data is already been tagged with the correct output. So sometime what happened ki, sometime we have given some input and we will not be getting the correct output as we desire it. So what we do, we keep on providing the training until and unless the machine becomes the experts. So this is what we keep on giving the training until and unless it will be giving the correct output as per our expectation. So in supervised learning, the training data provided to the machines works as the supervisor that teaches the machines to predict the correct output. It applies the same concept as I have already told you that as a student learns under the supervision of the teacher. This I have already discussed with you. Next is unsupervised learning. So unsupervised learning, as the name signifies, we don't have any supervision for that data. So for unsupervised means we don't have any supervisor, we don't have any trainer. So what the machines do, what they learn themselves. They try to find the hidden insights or the passive patterns from the given data themselves and try to learn the new things. So basically, what happened in this, uh, for example, as we are the adults, what we do, there is no supervisor who is guiding us. What we do, we keep on learning ourselves and we keep on finding the new things out of it, right? So unsupervised learning is a machine learning technique in which models are not supervised using training dataset. Instead, models itself find the hidden patterns and insights from the given data. It can be compared to learning which takes place in the human brain while learning new things. As I have already told you that as being a human being, we are the adults. What we do, we keep on learning from our experiences, right? We don't have any guide. We keep on learning from our experience and our day-to-day life. So unsupervised learning is the type of machine learning in which models are trained using unlabeled data set. So what we do basically in this, we keep on giving the data to the machine, right? So what the machine do basically, machine try to find the similar type of things together and they try to categorize those things in a one group. You can say that clusters also. Clustering is the part of unsupervised learning. What we do in clustering, we gather the similar objects in one clusters, right? So in the same way, unsupervised learning works. Unsupervised learning do what? It gather all the data which is having the same type of patterns or insights, right? So in this way, unsupervised learning works. Unsupervised learning is a type of machine learning in which models are trained using unlabeled data set and allowed to act on that data without any supervision, right? So now next topic is what is SVM? See, this is very important topic, SVM, because this is the main topic of ours. And machine learning, it is again a part of a machine learning. So that's why I've just discussed with you what is the basics of machine learning. So now I'm going to tell you about the support vector machine, right? So as I have already told you, key what is supervised learning and what is unsupervised learning, right? So support vector machine is a supervised learning algorithm, so which is basically mainly used to classify data into different classes. So basically what is SVM, why we use the SVM? Basically we use the SVM for the two things. One is for the classification and other is for the regression, but here we will be using only for the classification, right? So what is SVM? SVM basically you make the use of a hyperplane. Now the question comes into your mind ki what is hyperplane? So hyperplane is basically a decision boundary which will be acting as a decision boundary between the different classes. Basically what happens in the support vector machine, this I am going to discuss with you in detail later on. For a time being, you just understand ki what is hyperplane. Hyperplane is basically a decision boundary which is used to separate the two classes. What we do, we make one hyperplane between the different classes, and which is basically acting as a decision boundary, right? So SPM can be used to generate multiple separating hyperplanes such that the data is divided into segments, and each segment will only contain one kind of data, right? So SPM is basically हम क्यों use करते हैं? Why we use it? We use to generate the multiple hyperplanes. There is number of ways in which we can make the hyperplanes, and we will be discussing ki which hyperplane will be acting as a best hyperplane, and how we can make the hyperplanes in between the different datas, right? So how does SVM work? This is now where I will be discussing how basically the SVM works, right? It basically, as you can see that there is one figure in which we have two axes. One is x-axis, one is y-axis. You can mark one axis, horizontal axis, as a x-axis, and the vertical axis as a y-axis, right? And you can see that there are two different type of objects here. One is circle object, another is a square object, right? So what we will be doing, we will be drawing one decision boundary, and I have already told you that decision boundary is here acting as a hyperplane, right? So what is the purpose of the decision boundary? The purpose of the decision boundary is that to separate the two classes so that there will be no object which will be there in one class. Means one class will be containing one object, one type of object only. So hyperplane is basically separates two classes, and in which each class will be containing the objects of that class only, right? So basic principle behind SPM is to draw hyperplane. So you can see that I have drawn a one hyperplane, this straight line. This is not basically a straight line, but this is a straight line for separate these two objects, right? One is the square object, another is the circle object. So this is the hyperplane which I have used to separate these two classes, right? So basically we have two type of classes in this. One is opponent class, another is considered class, right? So that I will be discussing in the next slide. What is the opponent class and what is the considered class, right? So before discussing about the opponent class and the considered class, first of all, the question which comes into your mind is that why I have drawn a hyperplane like this. There are number of ways in which I can draw a hyperplane and I can separate these two classes. I can draw a hyperplane in this way. I can draw a hyperplane in this way. You can see in this slide, I have make three different hyperplanes, right? This is the first hyperplane. This is the second hyperplane, and this is the third hyperplane. You can see. So these are the three different hyperplanes, and which is separating these two objects, right? This is the square and this is the circle. And now the question comes into your mind, why we have chosen these three different hyperplanes, and which hyperplane will be acting as the best hyperplane. That I will be discussing with you soon, which hyperplane will be acting as the best, right? So you can start off by drawing the random hyperplane, right? So whenever you will be working with the SVM, you can draw random hyperplanes, right? Then we have to, what we have to do, then check the distance between the different hyperplanes and then the closest data points from each class, right? This is the main purpose of the support vector. Now what we will be doing, we will be studying what is support vector in SVM, right? So why we call it a support vector machine, right? First of all, let me discuss with you what is the uh, I have left one thing which is opponent class and the considered class, right? So first of all, I'm going to tell you what is opponent class and what is the considered class, right? So considered class is the class which we are considering right now, and opponent class is the class which is far from that class, right? So here you can see that we have two classes. One is the square class, another is the circle class, right? So what we are going to do, we are right now considering the square class. Right now I am considering the square class, and the circle class will be acting as the opponent, and the square class will be considered as the considered class, right? So what we have to do, this is the opponent class and this is the considered class. So what we have to do, we have to check a point from the considered class to the opponent class, and we have to check that point which will be the closest from the considered class. So as you can see that this is I have just told you that the square class will be acting as the considered class and the circle class will be acting as the opponent class, right? So we will be seeing this is the considered class and this is the opponent class, and we just see that the point which will be the closest to the considered class. So you just see if we will be considering all these points, okay? So this point is quite close, and if we keep on checking with the other points, this point, this is quite far, this point, this is again quite far, and this point is again quite far. So what we have to do, we have to consider the closest point in the opponent class. So point this point will be acting as the closest point from the considered class. So what we will be doing, we will be drawing one vector which is parallel to the hyperplane. This center line will be acting as a hyperplane, and we will be drawing one support vector in parallel to that hyperplane, right? So what we have done, we have drawn a one support vector which is parallel to this hyperplane, right? In the same way, now I will be considering the circle as the considered class, and the square will be acting as the opponent class, right? So when we consider this as the opponent class, then we have to, when circle will be acting as a considered class, so we have to check out the point which will be closest to this circle class, right? So circle class, the point which will be closest to the circle point, you just see these all points are quite far, and only this point is quite near to the circle class. So what we will be doing, we will be again drawing one line which is parallel to this line, right? So you just see that I have drawn a one line which is parallel to this hyperplane, right? Now, these are called as a support vector. Now, the thing which I have already told you, that now the question comes into your mind ki why we call it as a support vector, because these are the support vectors which are supporting the hyperplane in support vector machine. That is why we call it as a support vector machine. These closest data points to the hyperplane are known as support vector. That's why we call it as a support vector machine, right? Now the question comes into your mind ki why I have considered this hyperplane? Because I have drawn three different hyperplanes, right? So you just see ki I have drawn these three different hyperplanes, and if you will be seeing the different hyperplanes and if you will be making the support vector, there will be the different support vector for each hyperplane, because each hyperplane is arranged in a different directions, right? So if I will be making the support vector in respect of this line, the last line, the third line, then the support vector will be going somewhere in this direction. And if I will be considering the first line, then the support vector will be going somewhere in this direction, right? So this is how we will be drawing the different support vectors, right? So now the question comes into your mind ki which hyperplane will be acting as the best. So what we have to do, we have to make the different hyperplanes and we have to make the lines parallel to that hyperplane and which will be acting as a support vector. Now the next thing which we have to do, we have to measure the margin. What is basically the margin? Margin is the distance between these two support vectors. So this is the margin. So we will be now. I am going to answer you the question. Ki which hyperplane will be the acting is the best hyperplane, right? So the best hyperplane will be that hyperplane whose margin will be maximum, right? So you just see ki whosoever distance will be maximum, that hyperplane will be acting as the optimum hyperplane and the best hyperplane for our support vector machine, right? So this is how we will be selecting the hyperplanes, right? The hyperplane is basically is drawn on the basis of support vectors, and an optimum hyperplane will have a maximum distance from each of support vectors, and this distance between the hyperplane and the support vector is known as the margin. Now the question comes into your mind ki why the distance should be maximum. The distance should be maximum because if the distance should be maximum, then it will be very easy to differentiate the two classes. Because if some new object will be getting add on, then it will become difficult to categorize ki where I have to put that new object in the class 1 or class 2. If the margin will be enough, then it will be easy and there will be a very less chance of error and we will be getting a best result. Okay, this is the only reason ki why we consider the maximum margin, right? Now the next topic is types of SVM, right? So basically SVM is of two types. One is linear SVM, another is non-linear SVM. Now what is linear SVM and what is non-linear SVM, right? So as the name signifies linear SVM, so linear SVM is what it is basically used for linear separable data, which means that if a data set can be classified into two different classes just by drawing a straight line. So basically, if we are able to separate our data set into two different classes by just drawing a single line, then we call it as a linear separable data. Okay, as I can show you key what is linear SVM. Whatever we have studied till now, this is the linear SVM only. This is what I have told. What we are doing here, we have just drawn a straight line. On the basis of that straight line, two classes is being separated out, right? So this is called as linear SVM. See, this is optimum hyperplane because the distance between two support vector is maximum, right? Maximum margin. So this is the linear separable because by drawing one straight line, we can separate two objects, two classes in two different objects into two different classes, right? So this is called as linear SVM. Now the question comes into your mind, what is non-linear SVM, right? So non-linear SVM is basically is used for non-linearly separated data. Now what is the meaning of non-linearly separated data? This means that the data which cannot be separated just by drawing a straight line, then we call it as a linear non-linear SVM because it is not possible for us to separate that data by just drawing a straight line. For separating that data, we have to do some other technique, right? So I just show you the diagram. What is the diagram for non-linear SVM? So you just see that here a diagram is that there is a circles inside the origin, right? In nearby origin, and we have triangle outside that. Is it possible for you to separate that data by drawing a single line? No, I don't think so. If you try to do so, then it will be very difficult for you to separate that data into two different classes just by drawing a single line. So you just check it out ki if I will be drawing one horizontal line here, so there will be only two triangles on one side and others will be I mean there will be a mixed classes, right? So it will be very difficult to separate non-linear data by drawing a straight line. So we have one technology, but here I'm not going to discuss it in detail, but just I'm telling you ki what is basically that technique you, because that question might come in your mind ki what is the technique by which we can separate the non-linear SVM, right? So for non-linear SVM, basically what we use the kernel method. For kernel method we have different type of formulas also for kernel method. And basically if you want to know something about the kernel method, basically kernel method is the that method in which what we do if we our data is in dimensional, then we are going to convert that data into a higher dimensional, right? So suppose if our data is in one dimensional, in one dimensional means ki we have a one straight line, and in one straight line we have circles also on that line, and we have triangles also on that line. What we are going to do in two dimensional, we going to separate that circle and the triangle by converting into one more dimensional. That is, right now if we have one straight line x and y, then we are going to if we have single line, that is x-axis, then we are going to convert it into a x-axis as well as into a y-axis. Right now our data is in two dimensional, right? That is x-axis and y-axis. So what we will be doing in this, we will be adding one more dimension. For all non-linear SVM, what we do, we use the kernel method. In kernel method, what we do, we convert our data into a higher dimensional. So it is a two-dimensional data. We will be converting that data into a three-dimensional by making or by adding one axis, that is z axis. Right now we have x axis, we have y axis. We will be making one more axis in it, that is z axis. And if you see that if we will be converting into a three dimensional, then the data will itself will be getting separated out. And for that we will be using the different formulas that I will be discussing with you in my next slide. For a time being, thank you so much.